Hello everyone, today is our second lecture of the data science course and today we are going to talk about data preparation. So first of all, we'll talk about adding an index field using R or Python or how to do indexing in R and Python language. So first, why an index? An index field uniquely identifies each row in a dataset, making it easier to track and manipulate data. So we can add an index by which we can access, manipulate, or use that data or element, particular element. For example, we have a list or an array in which each element has an index by which we can identify each element. We can identify each element differently from other element. We can manipulate the data by using that index in the list and array. We can use the data by using the index of that element. So now we'll see how to implement that. So using built-in functions, we can implement it in our language. We use seq function for indexing, and in Python language, we can use enumerated function. These two functions automatically generate a unique index for each and every row. To each and every element, give an index which is unique and identical from other elements. Now we'll talk about changing misleading field values. First of all, we'll talk about identifying issue. So we can scan data for fields with ambiguous or inconsistent values that could skew our analysis. Means we can scan the data, we can see the data where we can have errors or which can cause inconsistency in the program, so we can change it by identifying it. Secondly, we can update their logics, so we can use leverage conditional statement like if else in R and if and else in Python to systematically correct problematic values. By using these conditional statements, we can overcome the identifying issues by, for example, we can update the logics. Like we can generate errors like in even number program if we want only even number. So using if we can only generate the even numbers, and when it come to odd numbers we can give them to else. So we can update these type of logics and can solve our identifying issues. Now we'll talk about re-expressing categorical fields. So first, by we can do it by standardized naming, so we can ensure consistent capitalization, spacing, and abbreviations for categorical values. Standardized naming is standardized. You by the word itself, you can think this is standardized. Means it's already defined. Means by for example, for defining a function, we'll write the function keyword or func keyword, or and then we'll write the name of the function. So standardized naming means when for naming the function, the name of the function is always starts with a lower letter. Means we can write it with small letters. We cannot write a name of a function with capital letter. Similarly, the name of the class is always a capital letter. So we'll name the class always with starting with the capital letter. Now we'll talk. Secondly, we can combine or split categories. So we can merge similar categories or split over broadly to improve analytical clarity. Means we can split the codes into different blocks so we can understand it easily, or we can split it in different ways. Like to we split functions like we have a function named sum for sum of the values. We have function name average for average of the values. So we can split the code in different blocks. So we can understand it easily. Now we'll see standardized numerical fields. We have scaling. So in scaling, we can see that we can use minimum or maximum or z-score normalization to rescale numeric fields to a common range. Now, second, we can have currency conversion, like converting monetary values to consistent base currency to apples comparison. Means we can do compare the values by using it. Thirdly, we have time formatting. In this, we'll ensure date, time, fields using a standardized format. For example, we have for the date, we'll write firstly we'll write year means y four times y for means the year, then dash, then month, then dash, then date. Now we'll talk about identifying outlines. So we have a pyramid-like structure. At the top, we have the univariate. Secondly, we have the multivariate, and at the end, we have the contextual. So in univariate, we can see that we can detect anomalies in individual numeric field using statistical thresholds. In multivariate, we uncover complex outlines by analyzing relationship between multiple fields, and in contextual, we consider the business context to determine if an outliner is truly meaningful or just a noise. Thank you. We'll talk about more topics in the next lecture.